All right. Hey, we got kind of cut off. We didn't get, I think, finish that last problem adequately. So the question was kind of, how do we find the solution to this system now? We've put it in row reduced echelon form, and how do we find the solution? Well, number one, as we discussed, it's going to have an infinite number of solutions because there are free variables, right? And we labeled these free variables. It was the x sub 3 and the x sub 4 variables that were free. Because there are free variables, we know there are an infinite number of solutions. And if there are an infinite number of solutions, then we're going to need to express those solutions parametrically. And so that's where I think the real strength of the row reduced echelon form comes in. So remember, this is how we did it. Once you have your parametric or your free variables, you go ahead and write them down and you assign a parameter to them. Doesn't really matter what. Let's call them S and T. So x3 is S and x4 is T. So wherever there's an x3, I can use S, and wherever there's an x4, I can use T. Well, if I then grab this first equation, or that first row is this equation, right? X sub 1 minus 2x sub 3 plus 3x sub 4 equals negative 24. That's what that equation would be if we were to just convert it straight back to equations. But we've got parameters for these variables. X sub 1 is, X sub 3 is S. So let's use an S in that spot. Plus 3 times x sub 4. X sub 4 is T equals negative 24. So I don't need to use the x sub 3 and x sub 4 anymore. They're my free variables. They're the two parameters. X sub 3 can be anything. We'll call it S. X sub 4 can be anything. We'll call it T. And what this allows me to do is solve for x sub 1 in terms of, just algebraically solve for x sub 1. And now I know what x sub 1 is. You give me S and T, the values for x sub 3 and x sub 4, I can now tell you what x sub 1 has to be. Okay, so let's keep track of that guy. That's the value for x sub 1, which comes from the first row, right? Well, now let's play the same game for the second row. The second row represents an equation, and it represents this equation right here. Zero x sub 1, right? And then x sub 2 minus 2 x sub 3, but I know what x sub 3 is. It's an S, plus 2x sub 4, which is T, equals negative 7. That's what the equation represented by the second row is, which tells me x sub 2 must equal, solve for it, 2s minus 2t equals, not equals, because I'm moving everything over to the right-hand side, minus 7. That is what x sub 2 is. Again, look, you tell me what s is, you tell me what t is, I can tell you what x sub 2 has to be. And then finally, the third equation is actually the simplest of them all. Let's just pull it out here. It's simply 0 x sub 1 plus 0x sub 2 plus 0x sub 3 plus 0x sub 4 plus 1x sub 5 equals 4. So that one actually has a specific value. X sub 5 has to be 4. So look, what's the solution? Well, x sub 1 is 2s minus 3t minus 24. X sub 2 is 2s minus 2t minus 7. X sub 3 is s. X sub 4 is t. X sub 5 is 4. So you are free to choose anything you want for x sub 3 and x sub 4. They do not have to be the same things. plug those values in where you see them for S's and T's, and that will yield all of the solutions to this system. Remember, there are an infinite number of solutions, and so we have values for these solutions. We just have to express them parametrically, and so we get the parametric representation very nicely and easily from the row reduced echelon form, because the first thing the row reduced echelon form tells us is what the free variables are and what we're going to be writing all the other solutions in terms of. In other words, we wrote all of the solutions in terms of x sub 3 and x sub 4, but we changed them to s and t so that we didn't have to keep messing with the subscripts. Anyway, I hope that's a better clarification than what we left off with at the end of class.